Apache Kafka has interesting message delivery guarantees, and these guarantees depend on whatever happens between the producers, brokers, and the consumers. In this video, we will test how Kafka handles at most once delivery, meaning messages may be lost or duplicated. We will intentionally crash a broker mid-delivery and verify what actually reaches the topic. But before that, let us think of an analogy to compare with Kafka's at most once message delivery. Think of it like the advertisement sales agent distributing pamphlets, letters, or papers on the street or door to door. These people or producers, if we think of Kafka, doesn't care whether you receive the message or not. They don't put any extra effort. All they do is to drop the message at your doorstep or mailbox. This is at most once delivery mentality. The producer with acks 0, retries 0 is only concerned of the message going through the wire. That is all. Whether the broker receive and forward the message to the consumer or not, that is not a problem for the producer, which means if the broker or leader of the partition dies after receiving the message, but before replicating it to all in sync replicas, and a new leader is elected for that partition, the message will be lost. We will see this practically in a moment. I want to thank you for watching this video. Don't forget to like, subscribe, and share. Let's get into that. We will start by checking and launching our Kafka cluster using Docker Compose. As you can see, this is Kraft setup with 3 controllers and then 3 brokers. So this will be our testing environment. I will share the link to the Docker Compose file in the comments. Let's start our Docker cluster. And one of the things I will do, I will not run it in daemon mode because I want us to see some of the logs and whatever is going on behind the scene. Now that our cluster is ready and running, we will clean up transactions IDs topic and create a new one with 3 partitions, 3 replicas, and durability with minimum in sync replicas of 2. The reason is to have a clean environment for the topic we are going to be doing our test specifically. So let's also look into that. First, let us list the topics in the environment and see how many do we have in our cluster. As you can see, we have other topics, but we will be doing our test with transaction IDs topic. So now I will also delete the topic so that way we know that we are starting with a fresh topic. If we are to go back and list again, we will see that the transaction IDs topic is not there anymore. So now we are going to create the same topic. And as you can see, we have a replication factor of 3 partitions and minimum in sync replicas of 2, which means now that our topic transactions ID topic is created. Now we will describe the topic to check which broker is the leader of the partition 0. This is important because we will target the leader of the partition in our failure test. Also, if we go back to our Docker and check the Docker PS, we can see that we have 3 brokers and 3 controllers. As I said, we are working with Kraft mode. So now let's describe our topic and to see what is there. For example, now we can see the leader of partition 0 is node 4. And if we check our Docker Compose file, we can see that node 4, that is this node, is actually broker 1. This is very important. Let's go back again and continue with our test. It is also a good practice to inspect the internal consumer offset topic. Let's also describe that topic and see what is going on there. And then we can use the same command, is just to change the name of the topic. So let us describe it. We have 50 partitions, and then we have 3 replication factor with minimum in sync replicas of 2. This is very important, because assuming if, let's say, the minimum in sync replicas of this topic is 3 and you shut down one of the broker, what did you expect? Also, optionally, if this default topic is actually having the settings that you don't want, you can use this command to change some of those things, but I'm not interested in that. Okay, now that we are sure our Kafka cluster is okay, let's go and check our Java application. In this application, I just have a simple controller that loops and sends 10 messages to the broker. And then if we are to look into the producer configurations, you can see intentionally I set the acknowledgement to 0 and then also the retries to 0. In this, I'm just telling Kafka that I don't care whatever happened, let's just send the message. And this is also one of the very important part of the at most once delivery. At most once settings, you are saying, okay, even if I lose a message or I get duplicate, I don't care. Yeah, we can also check our producer, not much there, except that we are specifically targeting partition 0. The reason of setting this to partition 0 is to be able to know which broker we are going to kill or interrupt during the message delivery. Producer sent message to only the leader of a partition. So that is why we are sending messages to this partition specifically. Consumer configurations also, like I have also set the auto commit to false. I want the consumers to commit the messages themselves. And also for the auto commit offset, if you set it to false, for that to be effective, you also have to set the acknowledgement mode in your Kafka or listener factory. Commit config, auto commit config, and the acknowledgement mode works together. Also, the polls per record or the maximum polls in a batch works together with the batch listener. So these are very important configuration. And let's look into our producer. We have checked it before, into our consumer. So now our transaction consumer will listen to messages and acknowledge them manually. As you can see here, after just receiving the message, setting the process time, updating the database. The reason of adding this is just for testing purpose. And then after each one, I am acknowledging the message manually. This acknowledge the process message. So now that our Java app, we have seen it, everything is okay. Let's also just run the application and let it stay or stand by. Our Java application is being started now, and the consumers and producers are ready to consume. As you can see, we have seen partition 0, partition 1, and partition 2 are assigned to this consumer. Let us go and try to send messages. So as soon as we start sending messages, we will stop the broker that is the leader of partition 0. This simulates a real crash during at most once delivery. So we are trying to simulate this, see how Kafka behave in this kind of scenarios. So let us go ahead and send the messages, and we also know that our command is ready to be fired and our message are ready to be sent. Okay, so now I will click send, go to terminal, and then stop our broker. So now our broker is stopped, and then let us go and see how our cluster is behaving. So if we can see from the logs of our cluster, we can see that we have gotten our node is actually shutting down. So shutdown completed. So this node is down. Kafka will automatically re-elect a new leader for the affected partition. So let us now check and see who is the new leader of our partition 0. Okay, now let's go to the terminal again. Then using the describe command, we are asking Kafka. So now you can see node 5 is the leader of the new partition. And if we come back here and also we ask Docker to see how many broker we have, you can see we only have broker 2 and broker 3 running. Let us now verify how many messages actually made it to the topic. Remember, with acks 0, retries 0, message loss is expected. We will go back to the other terminal, execute this command. Even though this command will just run and count the messages, but because we are just sending transaction ID to the topic, actually we can just consume the topic and we just send 10 messages. So we will be able to count them. So let me execute this command. This is my producer. Where is T5? So T5 is not here, but we have T6, 7, 8, 9. This is what is expected. So what do we learn from this? We have seen that Kafka batches messages, but delivery guarantees depend on producer config. At most, once deliveries means fire and forget. As far as the message goes through the wire, the producer doesn't care whether the message is received by all in-sync replicas or not. We also learned that monitoring internal topics like consumer offsets is very important. This is what it means when Kafka said at most once delivery. See you in the next video exploring Kafka's at least once delivery guarantee.